It's very important to understand the full process, and that includes fixturing, tooling, programming, and that's where we really shine, where we come into play.
I could watch robots all day long. And the machine is not bolted down. Oh my God.
Anything that can be done in-house will be done in-house.
Look at how big this is incredible. This is turned on a milling machine. Hi folks, possibly the factory tour that I am most excited for ever in my life. I am here in Gosheim, Germany with
Gunther Schnitzer.
And you are?
I'm the president and CTO of Hermle USA.
This is incredible. So I first learned about Hermle at the Deutsches Museum when I saw one of their machines, and then I've gotten to know the brand and how just amazing those machines are. I've gotten to know these guys. They're actually helping out with the Johnny 5 projects. More to come on that. They invited me over here to see their factory, which is pretty cool, not just because you build machine tools, but because you guys don't outsource.
Correct. We don't believe in outsourcing. So everything that can be done in-house will be done in-house.
Awesome. So where are we here?
So we're here in our lobby. We have a little museum back there that I'm going to walk you through and I'm going to show you in a little bit. But this is our lobby. We have a few show parts over here. And here is what we call the Lemberg Tower. This is a built-to-scale model by the apprenticeship department that actually is on that summit that you see over here. The region here is called the region of the 10,000ers. And this tower is on top and it gives you an amazing view of the valley and the company.
Yeah, you guys could see from the footage driving in here, we're in southern Germany. It's absolutely beautiful here, and it's kind of surreal because this is Hermle, right?
Yeah, this is a very small, little tiny village. About 4,000 people live here, but at the same time, this village offers over 2,500 jobs.
Wow.
Yeah.
But if you see a Hermle somewhere in the world, it was...
All of them were built here.
Built here, cool.
So we have over 27,000 machines in the field.
Wow.
And all of those machines were built here. They went through this factory.
Look at these. So one of the cool things too is they make a variety of size machines, but they focus on absolute high-end, top-notch 5-axis machines. So you can see, we'll see some small parts, but look at the side. This is off of the C62?
It's off a C40. It's
really?
actually an impeller, yeah.
That's not even as big as they come then.
This one actually we programmed in the US a few years ago.
Oh my
This might look familiar to you. That's the Matterhorn,
Okay.
Switzerland.
So lots of medical. Cool. What's the old horizontal?
And this one is year 57.
57.
Yeah,
Wow.
it's right here.
Look at that. You're not going to find these anymore, but still cool to see. And obviously, folks, we're not allowed to film here.
So this is what a watchmaker shop looked like in 1920.
Okay.
And here we've got an original desk from 1950. We got a time system back there. You still can see some of the original drawings here.
Oh, look at this. Just spindle. Yeah, that's awesome.
Also, the area is heavily rooted in the medical industry. So
Ah.
some of the largest medical device manufacturers,
Yes.
they're here within an hour. So some of the show parts, they might look familiar to you.
The heel.
The heel,
This is awesome.
We made that at IMTS 6
Amazing.
years ago.
With the tool sticking
Correct.
through the ankle into to get to the picking up his
all
corners.
true 5-axis. Probably one of the most challenging parts that show parts that we've ever made.
Yeah.
Yeah.
Fritz was pretty cool.
Fritz was pretty cool.
Yeah.
But the high heel, as far as accessibility to the part,
Yeah.
very, very complicated.
The thing that to me that was so cool about Fritz the Bull was, and card here to our IMTS video, was seeing how a Hermle can move around a large part. And I'm sure Fritz was aluminum, so perhaps not as heavy as some of the parts we're going to see on the
They're
62.
actually much bigger.
Yeah. The
More
spider.
heavier. We've had to write over 120 sub-programs in order to machine it, because it's obviously a very complicated geometry. You look at the legs of the spider, they're very thin.
Right.
And very complicated part.
That's cool. It's also awesome because I have a friend who just recently went and purchased a Hermle, and it was cool to hear his side of the story about what it was like going through that purchase process and understanding the kind of turnkey nature of the solution. And it's not just buying a machine tool, it's the whole spectrum of work holding and programming, how it's going to end up making that final part. And it was fun to kind of be a silent bystander on how that process is.
Yeah, we look at ourselves no longer just as a machine tool builder, because it's very important to understand the full process. And that includes fixturing, tooling, programming, and that's where we really shine, where we come into play.
Look at these. Probably titanium bone plates.
Bone plate, correct.
Total knee joints, hip joints.
Couple instruments over here.
Oh, really?
Yeah.
Oh, and these are off the machine?
They're off the machine,
That's cool. It's funny
Couple
because
tool
those aren't just demos. I mean, that's really tool. In fact,
Yeah,
in the
yeah.
Sandvik tour, we saw the Hermle
yeah,
machines.
yeah.
That's cool.
We have a lot of tool manufacturers that are using our equipment actually to make tool bodies.
Right,
cutter
right.
bodies.
It's funny.
So all the castings are stored inside for several days in order to acclimate, in order to guarantee the utmost accuracy from basically the stage of production till the final product.
Okay. So what we see here is pages painted, raw material.
Correct, correct. X slides, Y slides, table housings, everything.
Not yet machined.
Not yet
Yes,
machined,
okay.
but stored inside.
Okay.
Again, in order to acclimate. And then over here we have our mineral casting bases.
This is amazing, and so that's really cool. When we say the base on a Hermle, what you can see is you've got the tall columns that support your A-axis, and then you've got the rail system that would include not only your front to Y-axis rails, but then the rear side
Correct,
as well.
correct. And this is one solid piece. And it dampens the vibration, it gives you a solid platform, and it's very good the way it handles the thermal influence. So
Okay.
that's what makes an accurate machine.
And it's heavy.
It's heavy.
Very
yeah.
heavy.
Yeah.
Yeah. A friend who has a number of the Hermles, they don't actually bolt. They don't bolt them down, and
No,
you
we don't bolt
want
them.
them
No,
bolted
no,
down.
no, we
Right,
don't
they're
want
just
them bolted
rigid
down.
enough.
We need about 7 inch of concrete underneath the base, and that's it.
That's it. It's amazing. You can really see the size of the sort of smaller machine, and even just seeing how they handle it, again, with kind of the built-in chip evacuation, your front axis, it's amazing.
Yeah.
It's cool to see without the sheet metal on. Really gives you a sense of what it's like. Again, more castings, more parts. You can see, for example, on sort of probably one of the medium-sized machines, that would form your A-axis with the C right there on top of it. The tables, it's beautiful. Your Z column right there. There's such an emphasis on either manufacturing in-house or sourcing within, what did you say, 20 kilometers?
Yeah, basically.
And certainly within Germany.
Yeah,
Everything.
Everything 100% German made.
They've got the performance line, the kind of the 3 digits, and then the high performance, but still every machine is made here, which is different because there's some other tool manufacturers where different series of different lines are either made overseas, different factories, or even just third party. Not here though.
Yeah, no. Cool.
I love it.
So this is basically the starting point of the philosophy. So anything that can be machined on a Hermle will be machined on a Hermle. So we use our machines to make parts for our machines.
Right. That's amazing.
So over here we have 2 C42s. All of them are fully automated. They got extended magazines, an additional 472 tools on each machine.
Oh, really?
Here we've got another, that's a performance line machine, the C250. Connected to an HS Flex, the flexible automation system that we saw earlier this morning.
Do you normally use it in the automation mode, or do you ever actually?
No, for the most part, all fully automated.
It's absolutely amazing to see a lathe tool being held in an HSK spindle and the part rotating.
Making a trunnion,
Awesome.
producing a trunnion. So he's getting off a C-axis plate that was machined on the C52. What we got here is a C52, also mill turn.
62 or
52? That's a 52.
Okay.
It's also a mill turn. So, and that's a C-axis that was actually machined on this machine. This machine is connected to a PW3000. That's a pallet changer that can handle 3 tons, so over 6,000 pounds.
And the part that he's blowing off is a what? As a table for?
It's a C-axis of a, looks like a C42.
42. So you make a 42 on a 52.
Correct.
It's amazing. You see, I don't know if the size comes through, but these are incredible. Those parts are going to be in that cell.
Correct.
That's amazing.
Correct. You know, that tower magazine that I showed you down there? You know, it can go on from a C22 all the way up to a C62.
Yeah.
It's the exact same magazine, just the different interface.
Look at all of the tools.
So we got a
HSK 100?
HSK 100. We got a couple thousand tools just here in the production area. All of them are equipped with a Bellow RFID chip system. So basically, we set up the tools over here and then store all the data. And have a Bellow reader built into the magazine that transfer all the information into it.
The height comes through that way as well?
Length, radius, tool life, everything that you can think
of.
of.
But I saw a sticker on some of them, no? You still have a label on some.
Yeah,
I guess you need to know.
Just to verify. Just to verify. Because you know, you look at the insert tools, you want to be able to adjust each insert individually, and that's what we're doing here. And that's why this one has a label on it.
So this machine would do cast iron, almost all cast iron, right?
This is what we're doing on this one for the most part.
Cool. Look at how big this is. Incredible. How this is a 62?
This is a C62.
Oh my God.
So that's the machine that can handle Full 5-axis over 5,000 pounds.
With the way,
Yeah.
it's amazing.
Next to it, we got a trunnion of, that's a C32.
Which is large, I mean, but compared to this, it's nothing.
It's much smaller. So what we got here is, here we have two C62 mill turn
Yes.
machines, also connected to a PW3000 system.
Okay.
With up to 9 pallets in there.
This is, first of all, beautiful room, but huge.
Thank you. Yeah, this is very huge. We just added, so basically what we did is we built the building around this building in order to increase the ceiling height. And then what we did is from basically 5 meters, we went up to over 12 meters. And then we used the cranes of the new building to take the old building apart.
So this was an existing room.
This was an existing room, and then we built the building
like the
around the
Fabergé egg
building.
of buildings. It's hilarious. Oh my God. And look at, I mean, again, folks, the size of this is incredible. That's a 62, but that's also a 62 machine.
Yes.
So that piece will rotate around there and it'll feed through the front door.
Correct. So that's basically a platform. You have the 2 doors. Like
Okay.
you seen this morning.
Yeah.
You basically open the 2 doors, the platform moves down, then the shuttle can go in.
Okay. So the doors happen to be closed right now.
Correct,
Okay.
correct. So they're not running a machine right now.
Yes. It's beautiful. Wow.
You see what kind of part we got under. That is a trunnion of a C400. And then up there on the left,
62.
that's a C-slide of C22.
They were showing earlier on the round ones that they use for the mill turn, there's actually a stabilizing weight that they can adjust. So obviously offline, while the machine's running in another pallet, they can be setting that up, indicating, dialing in the fixture, and dialing in the balance of it, right? Is that what you would say? Amazing. This is C42, but this is what I was hoping that we would be able to see. This is turned on a milling machine. The IDs there, it's amazing. In a factory full of really cool things, it might sound silly, but this might be one of my favorite things. So you want to tell us what this is?
So what this is it's basically a chip conveyor, and this tool underneath here makes little brackets. And then we use a negative pressure system to basically suck out the brackets. And what's nice about this system is we can switch between materials. So as you machine cast iron, you want the little brackets going to a different chip in, versus when you do cast aluminum, then you update it with an M function, like on the fly, and you change between the materials.
It's amazing. Amazing. Also, thank you for not saying aluminum.
Yeah, thank you. So this is our latest edition, and what's really unique about this machine, it can handle up to 700 tools. So
700 tools?
700 tools. Look at that tool changer.
That's just the tool changer, right? The whole machine is actually back there.
Yeah, the whole machine's back there.
Wow.
And then it's connected to a liter FMS system that can handle pellets with overall weight up to 3.5 tons.
So what we're looking at there, the shelves on the wall are all an FMS system, basically a giant automation crane system that can move those into that 5-axis horizontal machine center. It's incredible. Amazing. We just were in the production side, the machining side, now assembly. This is beautiful.
This is one of the main assembly bays where we assemble the C42s and the C650s.
Okay. It's impressive the number of machines.
Yeah, we build about close to 1,000 machines a year.
Wow. Yeah. So this is constantly turning over.
This is constantly
they sit here for a certain number of days.
Every 10 days,
Okay.
the machines get shuttled out here.
And you move them with the crane system when they're done, or they?
No, we have a special lifting device that we use, not with a crane in here. So what's really kind of cool, the machines, they get assembled in a team, and so they're like electricians and engineers, and at the end, once they're done completing a machine, they basically put a sticker in the cable cabinet with their names on there.
Oh, who was part of it?
Because they're very proud about it.
That's cool.
And for a lot of pride in that.
Sure. Yeah. Wow. More assembly.
Yeah, more assembly. So this is an area where we assemble some of the performance machines, so the C400 and the C250s. And the way in the back, that's the area where we assemble the smaller machines, the C12s and the C22s.
Wow.
And the reason for that is basically because there's a floor underneath this floor, so we're on the second level, and obviously the payload is a little different versus over here we're on ground.
Got it. Yeah. If somebody is trained to assemble a C12, could they also do a C650?
Yes, basically.
Yeah. Wow. It's incredible.
So now we're entering the apprenticeship department.
Okay.
In my view, this is like a huge playground.
Yeah, right.
Because you got all different kind of technologies here. Over here we have a lot of manual milling machines as well as manual lathe. Over there we have all CNC control, Weiler lathe, and then a total of 4 5-axis machines. One actually is even equipped with a robot. So we want the kids, you know, to get into robots and automation right from the get-go.
So who is here?
So there are basically 4 instructors, 2 that oversee the mechanical part of the apprenticeship area, and 2 that oversee the electrical / mechatronics area.
And so most of the people that we see in the factory would have gone through this?
Yeah,
Some of them?
over 60% of the people that you see in the factory went through an apprenticeship program here. And over 10% of the current employees, and we have about 1,200 employees, they're part of an apprenticeship program.
Oh, wow.
Yeah. So
and this
like
isn't
100 people right now belong to this program.
Wow.
Yeah.
Okay. And this isn't just a 1 or 2 week training.
No.
This is a full-blown.
Yeah, it's a 3.5-year program.
Yeah. Okay.
So the first 12 months they spent in here to learn the basics, and after that they basically go through all the different departments to, you know, get hands-on training. As a matter of fact, they even travel with the service technicians because we want to show them what it's like out there.
Yeah.
Because it's obviously a different environment when you work on a used machine versus a brand new one.
So as you're trying to learn about different 5-axis machines and machine tools, one of the things that's interesting to me about a Hermle is there's a couple of different features that make them perhaps good for the long run. Number one is they've got this pretty unique ZE system, which basically if you have a soft crash, it will crush a series of washers, and there are things that can be replaced by service tech. Some companies even are trained to do it in-house, but it can save your spindle, so to say. And then there's other mechanical elements of the machine tool that allow Hermle to come in and fix the machine in the event it needs to be fixed, which is quite important to the long-term accuracy of a machine tool.
Because everything can be fixed on site.
Yeah, that's cool.
That's very important.
Right. You were telling me how important the actual geometric accuracy is.
Correct.
There's things you can do in the control that are good, but it's ultimately.
But the only thing that a software can actually do is optimize the positioning tolerance, right? But the DNA of the 5-axis is the geometrical tolerance, the flatness, straightness, and that's what makes a 5-axis a good 5-axis a better one, in my view.
It's beautiful.
Yeah. Very clean.
So there's people here every day.
Every day, from Monday through Friday. About 1.5 days per week they spend in school.
Okay.
But other than that, they're
so they're still in a form of education school as well.
Correct.
Interesting. In the area.
Yeah, correct.
Okay.
It's a dual program, and they spend about, like I said, 1.5 days in here, in the school, and the rest they're in here.
Wow. So this is done in conjunction with the education system.
Correct. Correct. We work together with the local schools.
Got it. That's cool. And many of them will then come to work here full time?
Basically 99% of them.
Okay.
Yeah.
Awesome. Wow. They were saying the white one, they have another one now that they shipped to the US in Wisconsin, but it was a restored version of an older Hermle machine. And so that's really cool. Hermle has been doing, we'll put a link in the video description, a very, very thorough US apprenticeship program that is basically influenced by the program here, which has that sort of German style apprenticeship program. It's very cool. So we're with Matthias.
My name is Matthias. I'm one of the supervisors from the training department. I work down in the Lomo, where we assemble machines with the trainees and service technicians and also interns. When the trainee starts their apprenticeship, they're here for 1 year.
Okay.
And that's the mechanical area. They start with simple turning machines or lathe machines. Just to get a feeling for turning, for different steels and materials.
Yes.
Then they go over to the milling machines. It's the same, first with easier machines.
So they're learning the basics of machining, the fundamentals of accuracy and making chips, tooling, and so forth.
About the tools, materials, to get a feeling for the machines.
Yeah.
Right.
Cool. And that's for a year, or a year in this floor, but only...
Right.
Okay.
Up here, they stay for a year.
Okay.
If you learn a mechanical occupation, you also go over to the electric area. So you will stay there for 1 or 2 months, just to get an overview about the electric stuff. Because we don't have only mechanics, we have also electricians. And it's good to know what does the other part.
Sure.
Because later when they work on a machine or when they assemble a machine, they have to know what does the other guy do.
Sure.
As you can see, we work with kind of older machines.
Yeah.
It's a UWF. I think, I'm not quite sure when it's assembled, in the 80s, I think. But it's the best way to get a feeling for making chips, tools, and other stuff.
Wow, yeah, quite the assortment of tooling. It's like a beautiful multi-flute heat shrink end mill and a manual machine. It's kind of funny.
It's manual, right?
Yeah.
What's really cool about this one is we just took delivery in the US about the exact same machine.
Yeah.
So we had the kids here, they basically refurbished the machine, and we just took delivery literally 2 weeks ago of the exact same machine that's going to go into our apprenticeship / ICAT area.
That's awesome. Yeah, these are the style where you can take the head off and turn it into a horizontal machine. That's awesome.
In this area, you can see the trainees working on the computers. They write their programs. And then when the program is done, they can send it over to the machine because it's all connected.
Yeah.
It's connected
so they're
to
learning
the network.
CAD and CAM.
The first step is doing it manual.
Okay.
To write the program
Hand
manually.
code, okay.
But later on, when they come to the second year of training, they do it with a CAD-CAM system. Right.
This is really cool. To be an intern and get to run a C22. It's amazing, or C12.
So after 3 months, they start with the CNC course. So after 3 months, they already start working with CNC machines, high technology.
Quite young to be doing that.
Yeah, right. You can be 16.
Yeah, it's amazing.
Working with CNC machines. Yeah.
Or to be 26 and have done it for 10 years, right?
Yeah,
that's amazing.
Right. I like it.
Yeah.
As you can see, we have also interns.
Okay.
And they work together with the trainees.
Got it.
So they come here for a week.
Okay.
Those are students.
Okay.
Students. We have a school down there. It's maybe 1 or 2 miles from here, and they come here for 1 week just to get an overview. What is the company doing?
So that would be before you're an apprentice. An intern is just a sort of a preview.
Right. Just to get an overview. What would I like to do after school?
Yes.
And maybe they have an idea after this week.
Yeah, sure.
And then they know, okay, I want to be a mechanic at Hermle.
Do you think in Germany, do you think most students know what machining is?
Some. I think in this area, most of the students or pupils know about machining. Yeah,
but it's not
because
everybody.
It's not
in
everybody.
In the US, it's very few. Many students would have no idea.
Yeah,
no clue.
I'm pretty sure a couple people in Germany, they don't have any idea about turning or milling.
Cool.
Yeah, it starts with an internship, and then you can do the apprenticeship, and after, you know what you're doing.
Yeah, right.
Good. So let's take a look about those projects.
Yeah.
So this level, water level, is one of the first projects the mechanics, mechatronics, and electricians do after the CNC course. They learn about programming in our training department, and then they write a program and prepare the tools and then mill it on a machine.
Sure.
This is a project they do on the lathe machine. It's a
flashlight.
Flashlight.
Yeah. They make that on a manual lathe.
They do it. They do every part.
Okay.
Over there we have 2 CNC lathe machines.
Oh, the teach style machines with the hand knobs and CNC.
It's something between,
Yes.
In between.
Cool. Yeah. That's beautiful. The interns do this?
The interns with us supervisors, they did it together.
Yeah.
It was a combination of Hermle and Heidenhain.
Ah, I see.
Heidenhain did the CAD-CAM data, and we milled it.
Is that a milled finish?
Yeah, it's with a special tool.
Like an MCD, a diamond?
PKD, I think.
Yes, PKD,
okay,
sure,
right.
sure.
Yeah.
That's insane.
But we got help from the
apps department, from an applications engineer.
Apps department.
Yeah.
Right.
And this is a project the interns do when they are here for 1 day.
Okay. Oh,
So
wow.
I was talking about the internship for 1 week.
Yes.
They stay here in the training department for 1 day.
Yes.
And the other 4 days of the week, they go through the different departments to
Wow.
get an overview about the machine. And on the day when they are here, they do this
They make
watch
That's cool.
or this clock. Another project for mechanics, it's the WISE.
Okay.
It's a combination of using the manual machines and
Okay.
the CNC machines.
Yeah. Interesting. That's
And-
incredible. Look at that. The ski boot mold. That's
Yeah.
amazing. Oh my gosh. Wow.
It's fantastic to see what you can do with the milling machine.
Yeah.
It's
Yeah.
with the 5X machine.
Yes. It's awesome.
And since 2 or 3 years we have a 3D
Yeah.
printer. And you can see it here or there.
Oh,
We
that's
can
cool.
print our machines
Yeah.
in a small way.
So we can even print the C62.
Everybody can have a C62.
You want, you can take one along.
Yeah. Carry on.
Yeah, carry on, yeah.
This is the electric area. So we go over to the electric part. On these first workbenches, you can see the mechatronic technicians.
Okay.
They are preparing for their exams.
Okay.
After 1.5 years, you have the first exams, which count 40% of all.
Okay.
And after 3.5 years, you have the rest
Wow.
exams. 60%.
So exams literally on the design of the automation systems, PLCs,
Right.
and pneumatics,
That's
hydraulics.
the PLC.
Yeah. It's incredible.
They get the program, but they have to connect it to the system,
Okay.
to the whole
To build this
system.
whole-
You can see cylinders, pneumatic,
Mm-hmm.
pneumatic cylinders, the valves,
Yeah.
the connection for the electric wires.
Yeah.
You have an alarm and
That's awesome.
a light,
Yeah. The tower.
and that's where all the wires are connected to the right port. You want to take a look in?
Yes.
Yeah.
This is so cool. Like, it's amazing. So they are literally still in school. So they take English class, but then they also come do PLC design.
Right.
That's awesome.
They have, as a mechatronic technician, you have a big overview because it's a combination of the mechanic part and
Yeah.
the electric part, and
Right.
of course you have English at school.
Yes.
Yeah.
Wow.
So you get an overview about the plug, the fuses, and other gadgets, which are
Because they're going to do this sort of work as when you assemble a
Later.
machine
Right.
downstairs. Yeah.
If you would open a switch cabinet of a machine, it would almost look the same. Of course, you have a couple bigger parts in
Okay.
the switch cabinet of a machine, but for, they are in the training for 1.5 years, and then they have to do this system. So
And you went through this program as well, or you were involved in teaching it?
I was when I started my apprenticeship here at Hermle 2010.
Okay.
Then after 3 years, my boss asked me if I would like to start here as a supervisor. So I stayed in the training department,
Yes.
but I went to the other side
Okay.
as a teacher.
Yeah.
Then after 4 years, he asked me if I would go down to the Lomo to assemble machines with the trainees.
That's amazing. Yeah. So they were saying they also, as part of your training, you also go downstairs where you're involved in assembling actual machines. So it's not just theoretical; it's
No.
practical.
Right.
Yeah. That's cool.
Yeah. Right.
Awesome.
Yeah, so that's, like I said, mechatronic workbenches, and over there you have the electrician
Okay.
people or students. Right now, I think they're at school,
Okay.
but they are also prepared for the exams.
Exams.
It's in the same week.
I see. Very cool.
It's almost the same, maybe less mechanic work because it's only for electricians.
It's beautiful. It's a beautiful facility. I mean, you could, yeah. It's beautiful.
I would say you have everything here.
Yeah.
You don't need more than this.
Yeah.
And our last area here is our training area
Yeah.
for
Yes. I see.
theoretical.
The classroom.
The classroom.
Yeah. Sure.
With a big screen and
And an overhead crane.
Yeah,
The student misbehaves.
I would say about a couple years ago, maybe 10 or 15, it was an assembling department up here
Okay.
where they use the crane.
I see.
But we don't need it.
Yeah. The soapbox derby.
Yeah,
The cars.
in our village in Gosheim, every year there is a race. And a couple years ago, Hermle, what
Helps sponsor and design.
right in designing, and also did the race.
Oh, did they?
Yeah, the trainees,
That's
they
cool.
were allowed to do the race.
That's fun.
Yeah.
Cool.
Yeah, that's it. You can see a really old machine of Hermle.
It looks like the one in the lobby.
Yeah, it's
the entrance.
Oh,
look at that.
As you can see in the
Serial number
in the
175.
50s. Yeah.
Yeah, so all of the machines are serial numbered sequentially. So this was the 175th machine produced, but it was produced here.
Yeah.
That's amazing.
All of the machines that we've built, and again, we have 27,000 in the field, they went through this factory. And the one that you saw in the lobby earlier, that was machine serial number 5.
Number 5.
Number 5.
Wow.
Yeah.
Amazing. I mean, literally, KUKA robot automation on a C12. It's amazing.
So here we're making the pan flute.
Oh, it's
remember
like
we had
from
that at INTS?
INTS, yeah.
Yes.
Right.
We're playing the national anthem.
Yeah.
It's just a smaller version. It's actually a very good example because over there you see fixture loading, right? And over here you got basically part loading.
Right.
Different size parts, and then again we have developed that software, the GRP software, you know, that you can easily basically update as you would change between different material sizes.
Okay.
Yeah.
In
So
terms
you
of the
basically,
interface.
you know, you look at the tray itself. You know, you would tell the software on how many parts you've got in X and how many in Y, and it would automatically update the pick and place program.
Okay.
So you don't need to know anything about programming the KUKA robot. We've got a software for that.
Okay. Oh, so you don't really need to
No,
use
you don't
the
need to know
pen.
that. No.
Really?
And also, when you look at the grippers, you know, so those grippers are manually adjustable.
Yes.
So as you change from one size material to the other, you just adjust them. You change the pick and place program.
Yeah.
And 15 minutes
And
later,
you
you're
go.
back in business.
That's cool. So they were explaining, you know, year 1, you're upstairs. Year 2, you work your way through the factory, and then year 3, as part of your sort of graduation year, you are down here building machines.
Right.
Is that right?
It's in the second year of training. You come here for 3 or 4 months, and in this time, as a trainee, you build up 2 machines and 1 additional magazine.
Okay.
And yeah, you have time in between 3 or 4 months.
Yeah.
Because you're a trainee, you have to get a feeling for all the parts around the machine. That's why we get more time to assemble those parts.
Got it.
When you
so
come
so
here-
slower, but the same standard, the same process.
Right, it's the same
very
standard.
thorough.
It's you have the same tolerances as upstairs. At the end, the customer doesn't know that this is made by trainees.
Yes.
I mean, we supervisors, we make sure that everything is fine.
Sure, sure. You're here alongside them as they do it.
Of course.
Yes.
We do every step together.
Right, right.
Almost every
It's
step.
amazing. Right.
So when you come here, you start with those components. It's
So that's what would hold your x-axis.
right. That's
Yes.
the y-axis. Then
Yes.
we put the x-axis on
Yeah.
and the z-axis, and when
incredible.
the component is done, you put it, completely on top of the machine.
Yeah, it's amazing. That all happens right here,
It happens everything right here.
including the electronics, the cabling, the servo motors,
Right.
everything.
Up in the assembly, it's separate. You do this on one place, this on the other place, but here you do everything. As you can see, you get over there the material, the panel, and
Oh, okay,
the
got it.
screen.
The supplies to put it together.
Of course,
Got
you
it.
get every supply.
So this machine is closer to being done, looks
It
like?
is almost done. This morning we did the geometry of the
Okay.
machine, and in a couple days we can ship it out.
Wow, that's very cool.
Yeah. And yeah, the tools we work with is like this. It's that's called Team Center.
Team
It's-
Center?
Right.
Okay.
It's a software from Siemens, and we use it because we have a 3D model of the machine, of the whole machine, and we can beside the blueprints, we can use it to assemble machines.
So this is the instructions, or this
Kind
is just
of.
a reference?
It's
if
one
you-
part of the instruction
I
because the trainee can look at it and disassemble the machine
Okay.
and see how the components are put together.
Got it. Wow.
That's one of the software we work with.
Okay.
But the basics to assemble a machine is always a blueprint and the electric documentation.
Okay. So 1, 2, 3 machines right now?
Right,
Go on.
because we have trainees here. The trainees, they build up 2 machines
Uh-huh.
and service technicians.
Oh,
So
okay.
new guys who decide, okay, I want to do service for Hermle machines. They come here, get trainings and training in different departments, and also they stay here for 6 weeks
Okay.
and assemble a machine.
Oh, really?
They
Wow.
assemble. That's a
that's
machine
really
which
cool.
is built up by service technicians.
Okay.
And yeah,
Even
like
the
I
service
said.
technicians, perhaps the U.S. would come here and do that.
Right, we had already.
Yeah.
There was one session. We had 4 service technicians from the US.
Okay. Wow.
So all our technicians that we have in the US, they have to spend about 6 months here to get
Okay.
trained before we actually send out in the field.
Good. Okay. Cool.
So they're all factory trained service
Yeah.
technicians. It's very important.
Awesome. Thank you.
Sure.
Can open it for
This
you.
is amazing. Look at this room. We were here a few minutes ago and there was a truck loading a machine and it's
Yeah.
already gone.
Correct.
Amazing.
It's real nice. I mean, in this area, we can load and unload 6 flatbeds at the same time.
6 trucks at the same.
Yeah.
Wow.
Yeah.
So you see the 2 doors down there. So you bring in the stuff here, but then also obviously ship out. So some of the machines that get built come via this massive crane over that free span and then down there. Amazing.
So we have 2 20-ton cranes that we can link together.
Okay.
So total capacity of 40 tons. And basically the
incredible.
entire material workflow goes through those 2 doors. So all the parts, all the castings come in
Yeah.
here, and all the machines, they leave
Go
the
out.
factory throughout that door. Or the 2 doors that we got over there.
And aside from huge machines, we found the single largest forklift I've ever seen in my life down there. That's amazing.
Yeah, it's a Versa lift, and we couldn't find a big enough forklift that can handle a C62 in Germany, so we had to buy one in the US and shipped it over
Haha,
here.
the U.S. wins.
Yeah.
That's awesome. That's funny. Not that that's a small forklift right there. I mean, that's a machine.
Yeah,
It's
that's
amazing.
a machine, yeah. It's
Oh
like
my
a
God.
C400.
Wow.
The ones that they use at IMTS,
Yeah.
is a 6080. And I think
This
it's
is bigger.
100,000 pounds
Oh
and
my
140.
God. There's a driver's seat or a remote
There's
control.
a remote control. You see the remote is
Well,
right
that's
there.
the problem. You've got some tiny propane tanks. You need,
Yeah, bigger ones.
propane tanks.
Like I said, it's not the most fuel efficient forklift.
Wow, that's amazing. The size of this room is breathtaking.
Can you imagine,
Oh my God,
You know.
swinging the machine.
swaying the machine and having those 2 cranes connected or linked to each other?
Oh my God.
It looks amazing when you have a big machine coming down
Yeah.
from that bay.
Wow.
Yep.
So a machine that goes to the U.S. goes on to a barge?
They basically go on a skid, and then we bring them to the port where we put the seaworth gray packaging on.
Yeah.
That's not done here.
Where would they ship out of across the ocean?
Oh,
though?
Hamburg,
Okay.
Bremen. Yeah.
And then just like that, we're in this beautiful, picturesque southern Germany. Gosheim. Where it is quite cold today.
Yeah, it is. So that tower that you saw in the lobby that was built by, got that scaled model
Yeah.
built by the apprenticeship department. It's right on top of that summit.
Okay.
And again, this region is called the region of the 10,000ers.
Yes.
It doesn't translate well, but we have basically 10 summits that are higher than 1,000 meter.
This place just keeps on going.
Yeah, so this is basically the area where we built the custom automation systems.
Okay.
So that flexible manufacturing cell, the RS2 that
Yes.
you saw earlier this morning, the cell that can handle pallets or fixture slash parts as well. And here are basically 3 systems. Exact same concept, same robot, can handle up to 500 pounds. Yeah, this is what we do here.
So these are inventory, or they're built to spec?
No,
for
they're
each
built to
shop?
spec. Actually, they all have a customer name on it
Okay.
already.
Got it.
So
Is that the same with machines?
same with machines. Yeah, all the machines that you've seen, they're already sold.
Oh, really?
Yeah.
Okay.
Yeah. And
Wow.
And again, you can customize those cells in a way based on your application, based on what you want to do with it. You could have them set up only for pallet/fixture handling, or you can have them handle different size pallets, parts. I mean, here's a good view of different size programmable grippers. I mean, basically everything that you can think of is possible and can be automated in a certain way. Yeah.
So you ship it to the customer.
Correct.
With the robot.
With a robot. Robot stays in there. So it doesn't take too long to set it up. And in this arrangement that you see here right now, you can have two machines, one on the left and the mirror image on the other side.
Is that often done to share?
Yeah, to share.
And you could do it with the second machine later?
Up to 3 machines. Yes, you can start off with one machine, have it prepped for a second machine or a third machine, and then potentially just add one.
But you don't sell automation for other machines?
No, we don't. Okay. Only for our own product.
Would you help somebody design an automation system that had something like a CMM in it, though?
Yes, yes. Yeah, we have several systems in the field. You can add a CMM, you can add a wash into the cell.
Got it. So this is either smaller parts or just lower
correct.
end of the automation spectrum?
Mainly part handling.
Yeah.
And this one has what I call a Cardex type, like a Remster type of system. So there's a tower here, and we have different drawers in there.
Oh, okay.
So obviously, which helps to get more parts into a very compact footprint for full 5-axis. Machining. Let's say lights out over the weekend.
Yeah.
You can get on average. You look at a block 50 by 50. You can have close to 100 plus parts in there.
Yeah.
And also, when you compare fixture loading with part loading, I mean, you have like 100, if you think of 100 fixtures, 100 times the cost of
fixtures.
It's incredibly.
Yes.
So it adds up.
I like part loading idea.
Part loading is the way to do it. Yes. So in here we make basically all different kind of fabrication, sheet metal parts, from enclosures, stainless steel enclosures to doors, everything.
You do everything for
everything we do in here.
It's amazing.
Yeah, from small little brackets up to the big doors that you've seen on the C62, everything is done in here.
And is that new, or you've often done?
No, we've always been doing that.
It's incredible.
Now we're entering an area where we have 3 Trumatic, so it's a laser punch combination machine.
Okay.
So you have a laser on one side, you can also do punching, you can do tap punching, and all that within one machine. And all the 3 machines that we got in here are connected to that central storage system. So for the smaller parts, you got 4 containers, you can rotate this, so they call it Truma sort. And the smaller parts, instead of taking them back into the central storage unit, so there's basically a flap in the center that opens, and then they fall down. Yeah, design job site.
So is this all hooked in with your sort of job planning system as well?
Yeah. It's all controlled through our management software that we use to manage, the production, and they're all tied into that. Yeah. And here you see all different kinds of parts, doors, enclosures.
Oh yeah, right. So not just for the machines, but for the automation as well.
That's a cable cabinet.
Yeah.
That's apart from a setup station. So all the entire sheet metal production is done in-house. So we're right now in the area where we make the extended tool magazines as well as the HS Flex, so the automation systems. So here's an HS Flex that's going right now through looks like a test run.
So what's the difference between this area and the building that we were just in that had the larger RS system?
So this is more of a standard automation system for us. We still can obviously manage different size pallets within that system, but it doesn't include, it's not in a sense where we have complete, where a 6-axis robot, with vacuum grippers and all kinds of, add-ons. So this is more of a standardized automation product, but again, can handle various size pallets.
Wow.
Within one interface, which is important because you think of 5-axis machining, what you don't want is you don't want to make a small part on a very big pallet, right? So in this system, for instance, can handle parts up to 800 pounds. You can have a big pallet, 500 by 400 millimeter in there, but what you don't want to do is run such a small part in there, right? So therefore, with the exact same interface, you can also have a pallet that's only 240 by 270. You get better access for the 5-axis machining.
That's awesome. The tool, we can show this? The tool changer?
Yeah, we can show it, just not into the details.
You're right.
But so this is how it gets shipped and how it gets delivered. And so it comes on wheels. So one thing that we always feel is very important is, as you commission a machine, you do not know what your shop is going to look like. And I think we just went through that a few weeks ago, right?
We just moved our shop around,
So, and what's nice about, and it's the same with the machines, you basically put them up on wheels, and within, let's say, 4 or 5 days, you can recommission a Hermle.
Okay.
Yeah.
Cool. Yeah, it's funny. There's been some pretty fun stories about where people have put machines and going through elevator shafts and windows,
moving
and doors.
them over router machine tools.
Yeah. It's awesome.
It's another one of the tower magazines. So this tower that offers an additional 192 tools.
Okay. So a standard C32 would just come with
36 tools,
yes.
And then you can add either an additional 50 or an additional 88.
Yes.
192, 472 tools.
Okay.
So you can connect two towers to each other.
How many tools can you add before you have to expand the footprint?
Basically 36, that's the max.
Okay.
Yeah, that's what you can hold in the pickup magazine, and from that point on you basically have to add either an additional 50 or an additional 88. But still very compact.
Yes.
And we have also developed our own tool management software. So it's a random system, it's not pocket coded.
Yeah.
You basically just give the tool a name or a number, and the software manages everything for you.
Got it. And on these, it preloads what you need?
Correct. So as soon as you would select the code,
yes.
in your control, you put it in the auto run.
Yeah.
It starts shuffling the tools back and forth.
Oh, really?
So it makes sure that by the time you need the tool, it's going to be there. It's going to be in a pickup magazine. So you don't have to worry about anything as far as the tool management.
Got it.
And this is our technology center.
Good.
And basically in here we have 9 different models. So from the smallest C12 all the way up to a C62, and they're all in here.
You got every machine? Every machine,
you get to see all of them.
That's amazing.
Yeah.
I feel like many showrooms will have a selection of their machines.
No, we basically have one of each, and also all the automation systems that I got to show you, we all have them in here.
So that's what's cool too, is to understand what, it's fun to talk about, but I don't understand certainly all the different offerings, what are good for what types of shop and production and so forth.
Yeah, no, I'll show you all that.
Cool.
So this is the smallest one. That's a C12.
It's not that, it's a good work envelope.
Yeah, it's a very good work envelope. As you know, we have 2 different lines. We have what we call a performance line and a high performance line.
Yeah.
So the C12 falls into the high performance line. It's our smallest machine. But what's really nice about this platform is you can have up to 73 tools in a very compact footprint.
Yeah. That's just cool. That's all your coolant system?
This is the coolant system. Yeah, it's an 80 bar coolant through, so 1100 PSI.
Yeah. Awesome.
Chip conveyor.
Right. And so this machine would be one of the mineral casting
Yes,
machines.
this has a mineral casting base, as you can see here in the bottom.
Yeah. Do you know how much this machine weighs?
About 7 tons, approximately. So,
US?
No, 7 metric tons, so it's about 14,000 pounds.
Yeah. Wow.
Maybe a little less. The base itself is about 3 tons.
Okay.
Yeah, so 6,000 pounds.
And the base itself would come up and include your A-axis joints?
Well, the A-axis is mounted into the base, and you'll see that in the production area.
Okay.
It's kind of hard to tell with the enclosures.
Right. Because it's not, a base to me would be something that kind of cuts off below, but your base actually comes up.
Correct, it's one solid piece.
Cool.
It's part of the modified gantry, or we'll show you the modified gantry, what it looks like as we tour the company.
Okay.
So we've introduced this system last year at IMTS. It's an HS Flex system. The reason why we call it HS Flex is because flexibility is key. Our overall goal when it comes to automation is basically to increase the spindle utilization. So what this system can do, and as we can walk in,
we can step into the machine.
Yeah, we can step into the machine. That's also unique about all the Hermle automation systems that we built. We basically have 2 doors, and even on a flexible automation cell, the only thing in order to turn this into a standalone machine is you close those 2 doors. So during the day, you do the more complicated jobs, and during the night you run it fully unattended.
This is literally what I want. You have a regular machine, play around during the day, do what you need to do, and then shut the door and have it go to work.
Correct. Let it work for you during the night.
Right.
Yeah. So what's really unique about this system, over there you see different size Aroba MTS pallets.
Yep.
And on the bottom you have what we call an Aroba MTS pallet with a ITS chuck on top. So as you would select an ITS pallet, the robot then knows that this power or adapter chuck needs to go in order to run the smaller pallets.
So switch between the larger, almost like a horizontal style, to the little guys. Huh. Okay. And that's what that first adapter is?
Correct, that's the adapter. So here's an automatic gripper. So what the robot would do is... That's for the robot. So the robot puts this pallet in with the ITS chuck on top, then changes the gripper, and
then
from
it can
that
use
point
those
on,
things. Got it.
And you can customize the way you want this system.
Yeah.
So you can get it with 1 storage unit, you can get it with 2 storage units, different size pallets.
Okay.
Again, the reason why we call it Flex is because we want to offer a flexible automation solution / system.
Got it.
And you think of 5-axis, accessibility is key, because the last thing you want to do is run a very small little tiny part on a big pallet, because then accessibility becomes an issue. So having such a flexible system, you can, within one interface, you can work off different size pallets.
The difference though with this system is that generally you're going to have your workpiece is going to be kind of prepped on a pallet.
Correct.
Because I've seen your other systems of yours that can actually do robot loading.
Correct. So you can look at this, a lot of people refer to it as pallet load and unload, but I look at it as a fixture loading concept, because in every pallet you're either going to have a part or a fixture, versus we also have systems where we actually just put a fixture in and then transport the blanks, the material itself.
Okay. And so if you, to load and unload these, you would just call these individual things over to the tending station?
Correct.
Cool.
So we call it's like a drag and drop interface, because what's really important is that it's simple to use, and you basically have a software here, and as you would need a certain pallet during the day to set up the jobs, you just click on it, move it into the machine, and it automatically transports it in there. So in this system, you can have up to 50 pallets in there.
50. So that's a bigger area, or
no? It's the exact same area, but we add another two additional level of shelves.
Okay.
And then you can have up to 50 pallets in there. It can also transport an HSK 100. For instance, everything that use an HSK 100 as a pallet interface. So we can have an HSK 100 integrated into the table, and have an HSK 100 here
as a workholding.
As a workholding, utilizing it as a pallet. Yes.
Oh, interesting. Is that common?
Yeah, we do that quite a bit.
Oh.
Like the high-end controller nowadays, all the machines come with a touchscreen, and obviously pretty intuitive to use. Nowadays we have 3D model of the machine. I mean, what you don't want to do on the control nowadays, most of our customers don't program on the machine.
Right.
But it should be easy to operate, easy to understand, So you click on the chip conveyor, for instance, and it tells you straight away, okay, the options,
Right.
You don't have to use heavy cycles or a lot of soft keys, to click through. Right. It's pretty simple and intuitive to use, So all the machine, emulsion mist extractor, and so on. So
this is Heidenhain, or this is Hermle?
This is Hermle, and pretty new, so that's pretty much going to be on all the machines from now on, So.
Got it. Yeah, I like that. I like touchscreens. It makes it quite.
And again, you pretty much see everything you're gonna need. Like external coolant, whatever. And then you jump into that, and very easy to program, operate, and run the machine, right?
Cool.
And it's basically the same with the automation system. A lot of systems, they can be very intimidating.
Yeah.
So, and again, for us, flexibility is key. So we want to have a system that's easy to use, and that's why we've developed, touchscreen capabilities, drag and drop capabilities. That is important. I think you looked at that at IMTS. It's a monitoring software, HIMS, Hermle Information Monitoring Software that we developed. So what's nice about this system, you basically can tie all the Hermles that you have on your floor into this software. And for instance, it will tell you how much longer this machine is going to run till a certain tool needs to be replaced. Because the last thing you want is you want to leave on a Friday, and then an hour later machine stops because tool X is missing.
Got it. So this is the industry 4.0 stuff.
Yes.
Yeah. So the 3 digits, like the C250 is the performance line, which is just a step below the high performance line, which would be things like the C22. But similar-ish design, we'll see it later, but the casting, which in some of these is a mineral casting, is the base, but the base is both the rail here, but it comes up, so you can see it's a modified gantry, they call it. So you've got your y-axis rails right there, and then x-axis is in your head this way, and then the z comes in and out this way.
This is my favorite system.
This is insane.
Yeah, this is insane. It's a KUKA robot that can handle up to 500 pounds. We call this system an RS2 Kanban system. So what we've got here is, the system is built on the principle of having various size materials, fixtures, and tools ready to go. And I'll explain to you in a second how this works. So here in the back of the machine, this is what we call the Kanban part of the system. So where we have several chutes, and basically the way this works is...
Oh, that's the raw material.
Yeah, it's the raw material.
No kidding.
Yeah. And if a chute is empty, the robot would notice that and go automatically switches from one chute to the other.
It knows if there's
It knows this one is empty, it goes to the next one.
Yeah. This is amazing. So you just... Oh my gosh, so you could program multiple different high mixed parts.
Correct.
Wow.
And it's the ready to go approach, because everything, you have various size materials, fixtures, tools ready, and then as you would receive a 3D model from your customer, the programmer will basically just select a certain predefined material size, and from that point on, the robot knows which fixture is going to be needed, which gripper is going to be needed in order to machine off that lot
so
size.
if you switch your stock size, it can automatically flow through, cascade through what to change on your vise.
Correct. It does that all for you.
It does. That's awesome.
And you can tie it into an ERP system. So within SAP, you will create a job, send it over, and then the system automatically.
So that's crazy. So think about this: you're somebody issues a PO or you get an online order. That ERP minimum trigger can actually tell this machine to go ahead and make more parts. That's automation at a whole nother level.
Correct.
That's awesome.
And in addition, we have what we call a transport band here. So as you machine the part, you can do the 6th side, and then the robot puts it on the band, which is a programmable band, and transports it out of the cell.
Just finished parts.
Yeah, finished parts. Got a setup station here.
Yeah.
And then again, similar to what you've seen on the HS Flex, you basically close the door and it becomes a standalone machine.
Right. Dude, it's an amazing robot.
And also, you can put this on a rail. So if you want to tie in several machines, you just basically put this robot on a rail.
Okay, so the automation will service multiple machine centers.
So what you see here, with this system, we can support up to 3 machines. If you want to add more machines, then you put it on a rail.
Got it. It's an interesting point, because before I'd always been a fan of just add more spindles in discrete form versus things like a automation or a pallet loader. But one of the things that we're now realizing is we've got expensive tools. Like our digital boring head is not an inexpensive tool. So when you tie in machines across true automation, number one, you can share tools potentially, and number two, you could tie in things like different types of machining centers. So they could go from a 3-axis vertical to a 5-axis, or from a 5-axis over to a CMM, all like the Milterra tour we did, which that's awesome.
Yeah, especially, you can look at it in a way, oversized tools that will not fit into a magazine. The robot can load and unload for you, which is really kind of neat.
Got it.
And then you look at expensive tools, such as a U-axis, a tool that's worth $50,000-$60,000.
What is a U-axis?
Is a U-axis, it's basically an axis. It's a tool that you can control. It has a servo motor built in with a feedback system. So which allows you, to generate like turning surface finishes, with one tool. But then again, that's a very expensive tool, and you don't want to have one in each machine. So you can have the robot, share it between all the machines that are tied into the cell. So this is
bigger blocks.
Yeah, bigger blocks
too.
The ones that do not fit. So it's the other side now that we're looking at of the Kanban system. So the blocks that do not fit into the Kanban or into the chute, we put on what we call a matrix pallet.
Right.
So, and this is a system that is easy to adapt and change. So as you look at the pallet itself, we have developed or designed a software. It's called a GRP software. It's a graphical interface, and basically as you switch from a job, you just tell on how many parts you have on your matrix pallet in X and in Y, and the robot will automatically adjust the pick and place program for you.
Okay, so you don't have to program
so
with
you don't
the
have to program the robot. You basically just program the software.
So does it picks that tray up and it puts that tray
puts
right
the tray
here?
on what I call a staging station.
Got it.
Puts it on there, and then again, as you would tell the software that this is the size block that I would like to machine, the robot knows this is the matrix pallet, needs to go in the staging area. In order to machine that, I have to bring down the fixture that's located in position 19, and then switch to the gripper in position number 14.
Right.
So it does all that for you. You don't have to worry about it.
Holy cow. Yeah, it's amazing. It's amazing. Oh, look at the part up there. That's cool. And then the crown.
Large aerospace part. Yeah, that's the part you see at Milterra.
Amazing.
Canada.
That's a big robot arm.
So this one can handle about 270 kilogram, so like 500 something pound. So basically the way this is designed, you can have a mirror image of this machine on the other side. You see those two doors?
Right.
Yeah.
It's amazing.
So you can start off
two without a rail.
2 without a rail.
3 you need a rail.
3, well, you can have 3 without a rail, but then obviously you would
you sacrifice.
Correct, you sacrifice 1 rack space, but 3 without a rail, and then up to 8, 9.
Right.
Many you want.
And this whole thing itself is scalable in size, especially with the rail.
Setup station over here. It's a Nova MTS pallet.
Oh my God, it's beautiful.
So we have developed what we call a system table. You know, a lot of the, you know, the trunnions that are out in the field, you know, you have a C-axis and then you mount the receiver plate on top, right?
You lose Z-height.
Correct, you lose Z-height, exactly.
Right.
So we have developed what we call a systems table, where you can actually mount the 0-point clamp right on top.
Of the table. Got it. Yeah, I like that. So that's how you order from the machine. You order the machine that way, though.
Correct.
Right.
Correct.
All right.
You're gonna see that matrix pellet now. The big one. It's gonna bring that out.
I could watch robots all day long. Think about how heavy it is too, and it's picking it up at what is effectively the worst point. Relatively quickly as well. Oh, it's still leaving it right over there. Wow. Look at that. That's amazing. Yeah, there you go. Boom, there it is. Wow. Yeah, those are not light. Holy cow.
So basically all the parts that are either too heavy or too big for the can van,
Yeah.
you put them on the matrix pallet.
Right. Wow.
Now the robot knows what fixture is needed
Okay.
in order
Ah.
to handle that size part
Oh my God, look at it.
or that
In the
size
machine.
block. The fixture goes into the machine.
That's gonna change the gripper?
Yeah, it's
Okay.
automatically going to change the gripper.
Look at that. Oh my God. You see that it tilted the table? Oh my God, it moved
Yeah,
your
you
A-axis to
automatically
present
A-axis.
it to the
Correct,
part.
Correct.
Oh my God.
And once you're done with op 10, you can also use the robot to basically flip the part and
To do your
to
six
six
sides.
sides.
Yeah, right. Yeah. That's amazing. So the machines have, is it pneumatic or hydraulic through the table?
This one is pneumatic.
Okay.
So the interface, the roll interface is pneumatic. The chuck that's on top, that's hydraulic.
Oh, it has both.
Yeah, it's both, yeah.
Okay,
Yeah, yeah.
and they're both
So-
M codes
yeah.
or controllable
No,
through.
it's all controlled through the program of the robot. You don't
Okay.
have to worry about that too.
Got it. Wow.
That's that for you. As a matter of fact, we also have chucks that can automatically, you can program the position of the jaws. So then they can cover a bigger range of material
Without having to adjust.
without having to adjust them.
That's
And you
amazing.
basically save space in here.
Right, well,
Yeah.
and buying another, whole
right.
other chuck.
Correct.
Wow.
So having one vise that, let's say, can cover parts diameter 100 all the way up to 250.
Okay, and so and then it still has, that's amazing. Right. Oh.
So and with that, the programmer just has to basically place the 3D model in one of the predefined sizes and programs from that point on.
Right.
Can
Yeah.
use, feature recognition, all kinds of, CAM tools
Right.
in order to automate.
We just got our UMC 750. We're already starting to play with this idea of just using a single point to run all your programming off of, so you can actually even minimize the probing work. I could watch robots all day long. Oh, I hope it comes through on video how big this is. I've seen a 52 actually at 2006. It was a 52, right?
Yeah, that's the one we had at IMTS 2 years ago.
Yeah.
Where we made that huge fan.
Huge.
Yeah,
Right. But oh my God.
Basically exact same configuration. Also has a mill turn with a Siemens control, and we did all the turning and 5-axis
So when it
machining.
does your mill turn, you'll move to a Siemens.
No, it's available in Heidenhain and
As well.
Siemens.
Okay. So see that little MT right there? This machine can also what did you say the RPM is?
400 RPM, 1.5 tons.
Can hold 4,000 pounds?
Milling wise, we can handle over 5,000
But,
pounds.
yeah.
Turning, it's 1,500 kilograms, so 3,000 pounds.
3,000 pounds. That it can rotate at 400 RPMs. And so you would actually put a turning style tool in your spindle and rotate that and turn apart. It's incredible.
And what's really neat or unique about this is we can do the turning on what we call A0, but we can also do it on A minus 90 or any angle in between.
Right.
And in addition to that, we can do what we call interpolation turning, with those machines, and we can do simultaneous turning. So as a, in a way where you would actually, while you do the turning, so while
You're
the C-axis,
moving
while the C-axis is spinning, you're actually rotating the trunnion.
Sweeping it through.
Right. So which allows you to use a much shorter tool,
You're right.
do more aggressive cuts, stay closer to the nominal contour.
Right. Yeah, it's just like why you have a 5-axis and tilt for reach, but with turning while it's rotating.
Correct. So it looks impressive, and we have 130 degrees of travel in this trunnion. So, and as you see, big parts spinning at 400
Oh my
RPM,
God.
bringing down the trunnion, it looks pretty impressive.
Yeah. They're going to make us a pretzel. That's cool. Is there a machine, I don't know if there's a way to ask this, but is there a machine that is the most popular size, like the sweet spot within the Hermle?
C42.
Yeah, okay.
Yeah, definitely. 800 millimeter machine.
It's incredible. That's your x-axis.
Yeah,
Wow.
And what this machine can handle is, it can handle up to 1,400 kilograms. So that's like 2,800 pounds.
Yeah.
Which is unique.
But that has to count for your work holding as well.
Correct.
Okay.
Correct.
And so this would not be automation, right? Because this is just
No,
your standard
this is just a
C-slot.
standard
Right.
C-slot axis. But what's unique about this system, you can work off side plates. So where you can have up 10 here,
Okay.
you could have up 20 here,
Now-
and do a full 5 axis in the center.
Got it. So we're going to turn that block, hopefully, into a pretzel. And now we're with Michael.
Yes, I am.
Good to meet you.
Pleasure.
I'm excited. I'm hungry.
Oh yeah.
I'm hungry.
I'm not really sure if you want to eat that.
For some
but,
aluminum. Is that aluminum?
No, it's steel.
Steel. Okay.
Steel. So then, just start the program.
You cut steel dry a lot? Yeah. Are you cutting dry for filming, or you would normally cut this dry regardless?
It depends a lot on the material. I mean, if it's possible to be cut dry, then we do that.
Yeah. Oh, look at that. The speed. That's a HSK 63 spindle?
Yes, it is. 18,000 RPM.
What is the RPM on the anvil?
The anvil right now is roughly 10,000 RPM.
Wow.
Yeah.
So 12 millimeter end mill, so just about half an inch running at 10,000 RPMs. To say the least, high-speed machining strategy. Oh my God.
Yeah, I just found some information about the holder. It's a colored holder.
Oh, wow.
The company is called
Varian. Very high quality.
And this is those are the specs or the numbers.
So it's a collet style.
Yeah, it is.
Okay.
It is. Yeah.
So this is a traditional setup sheet you would use for a job?
Pretty much.
Cool. Ooh, high feed mill. It's so quiet.
Yeah, this is a product from Iskar.
This car? Okay.
Yes.
It doesn't quite look like a pretzel yet, but it will turn into a pretzel.
I believe you.
Actually, here are the specs if you want to.
This is the
It's a
tool we're
metric,
using now.
but at least to see some of the numbers.
Yeah. So 40 millimeter diameter, running at 300 surface meters, probably 2,500 RPM speed. The chuck is a hydraulic assist.
No, this is a manual.
It is, okay. Oh yeah, that's what we're going for?
You can restart if you want. Quicker than.
That's a traditional Heidenhain.
It's a Heidenhain PNC 640. It's really cool.
Sweet.
Look at the simulation. You can rotate the part.
This is no touchscreen.
Sorry, we're in the...
It's old-fashioned, but you still can rotate.
For the latest generation version,
yeah.
with a touchscreen, you
Yeah.
can rotate it.
And does this have any sort of a collision?
No, this doesn't have a DCM active.
Okay.
Collision is mainly done with using, different software
Yeah.
tools because it's just much
True path or whatever, yeah.
Correct. Much faster.
Right. I'll have to get them to tell us about it, but one of the, I believe, unique things about many or perhaps all of the Hermle machines is they have a crush washer in your spindle. So if you do have a Z-axis bump, you've got to have a service tech come out and they've got to fix it, but it minimizes dry. Wow. Holy cow, that's slotting?
Yes, it is.
Oh my god. It is silent.
It's a 16 mil.
16 millimeter end mill in steel. Looks like over 1.5 times depth slotting. That's impressive. What is the horsepower?
Oh, I couldn't tell you the horsepower. Here you see the kilowatt.
You got the equivalent?
This one
We'll
is-
convert it.
So 180 newton meter and 20 kilowatt. Swerve cut with true 5-axis.
Yeah. Beautiful.
As you can see, the way the axes move, very smooth.
Fluid.
This is
Right.
this is what you need if you're looking for high-end surface finishes.
Right. Wow.
Look at that ramp.
Yeah, that's incredible.
Pretty impressive.
It's incredible.
is really what makes a good 5-axis, a high-end 5-axis, seeing on how the axis
Look
move,
at the ramp.
how smooth, how...
It's incredible.
Look at it. Look
That's
at that
cool.
dynamic.
Right, two different ways to cut the same feature. Oh my
So look at the acceleration on
Right.
the linear axis.
You barely even see. Is that a solid carbide high feed?
This is an end mill with a corner radius.
Ah, okay, just a short, stubby bull nose.
Yeah, it's more or less just material removal, material removal.
Yeah. This is the dynamic. So this is the high feature option on the high end machine.
Correct, correct.
This is as good as it gets.
The only one that is a little more dynamic than this is a C22, because on the C22 we have 1.5 G acceleration, the linear axis.
Got it. And so when you're doing these sorts of moves, it is applying a mechanical brake to the A and C?
No, it's not.
Doesn't
it's
need it.
not, no.
Okay.
So there's no mechanical brake in A. We do have one in C, but we only use that when we put like real heavy parts on there.
Oh, really?
And then you
Okay.
can actually clamp it with an M function, but no mechanical brake on the A axis. So, and we've got obviously, we have a dual drive system, so we have a motor on the left and one on the right side. We run. And also, what's really nice about this system is, or the setup is, you can, let's say if you would ever bump the machine, you can actually realign the trunnion within space. So it's a patented system that we have developed.
Okay. But the parts that we're looking at, the whether it's just the platter, but also this giant
Yeah,
A
the
axis,
trunnion,
you
yep.
make that?
Yeah,
Here.
everything.
Oh, that's so cool.
Yeah, a little bit of finishing.
I like that. It continues around to pick up the next feature versus doing an unwind or a rewind. You can see too, it's hard to tell, but you're not, you're cutting with the side of the tool. The spindle's not normal to the feature. So in sort of a tilt angle. And it is true sight. You can see the knuckles are moving, the A axis. Yeah.
So this is almost finished.
Whoa. Is that a flat drill?
No, it's
an
but
end
it's a 3 fluid.
Wow.
So this is it.
So here's your pretzel.
Just unship
Wow.
it.
This is what I was talking about earlier. You know, you look at the travel.
Right.
And you can obviously turn the trunnion in both directions.
It does go both.
It
full.
does go both, yeah.
Wow. Obligatory chip dump. I like, that's interesting, the washdown hose is inside the machine. Whole thing is dry. Awesome. Yeah, it's incredible. It's incredible. Oh my God.
So 130 degrees.
Dark side of the moon back there. Wow.
130 both ways.
Yeah.
So you look at some of the aerospace parts, you know, you look at, you know, the leading and trailing edges of some of those rotative parts, they do require a lot of travel in the axis. So both ways, that's why we have 130 degrees in both ways.
Awesome. Awesome. Thank you. Wait for it. Wait for it. Is this real time? You're just using the feed rate override? Yes, yeah. Yes, and faster. It's incredible. Oh my. That's 100? 75? Oh my. And the machine is not bolted down. Oh my God. It's actually a little scary to stand in front of it right now.
So this is next.
That's it? Folks, I hope you learned something. I hope you enjoyed. A big thank you to Hermle for letting us come in and letting us film. The hospitality has been spectacular. The machines are amazing. Really, it's been a fun time. Take care. See you soon.
Thank you. Thank you.